Greetings to every one of you. In this video, we are going to discuss a topic, mathematical functions used in data structures. Let me start from the function, that is floor. So floor of x, this will return the greatest integer that does not exceed the value, that is x. For example, the floor of 3.14, so this will return a value, that is 3. So it return the value, that is integer, but which should not exceed the given value, that is x. Similarly, floor of minus 8.5, so this will return the value, that is minus 9. Okay, so the value should not, that is exceed this. Okay, so minus 8.5, so automatically you will get the lesser value, that is minus 9. Similarly, the next function is the ceiling of x. This is symbol, so just the opposite of the flooring, which denotes the least integer, that is not less than x. So whatever the value that is given, the value what actually the return, that should not less than the x. Okay, so ceiling of 3.14, so what will happen, this will return the value, that is 4. So integer not less than the given value, so 3.14 will become 4. Similarly, as far as ceiling is concerned, ceiling of minus 8.5 is equal to, it is minus 8, the greater value. Okay, so this is minus 8.5, so the higher value is 8. Similarly, if x itself is an integer, then this floor of x and the ceiling of x both are equal. Otherwise, the floor of x plus 1, that will give you the ceiling of x. So you consider this example in which 3.14, floor of 3.14 returns the value, that is 3. But whereas in ceiling 3.14 returns a value, that is 4. So 3 plus 1, you will get the value, that is 4. So floor of x plus 1 gives you ceiling of x. So that is the idea you should remember. Floor of x plus 1, that will give you ceiling of x. The fourth one, a remainder function. It is a very important function as far the programming language is concerned. In order to solve many problems, we have to use this function, like finding the sum of the individual digits or generating the Armstrong number, etc. We need this remainder function. If k is any integer and m is a positive integer, then k mod m, that gives integer remainder when k is divided by m. So for example, 25 mod 8. So 25 is the dividend and 8 is the divisor. Just divide 25 by 8. So the answer is, okay, 24. The balance is 1. We have to consider only the balance. So 3 8s are 24. The balance is 1. Okay. So similarly, 34 mod 6. 5 6 are 30. So you will get a balance, that is 4. Right. So here the dividend value is lesser than this divisor value. So that being the case, simply it will return the dividend as a result. So remainder. The next function is integer function. It's also called the int function. This will truncate the fractional part of the given value. See, for example, integer of 8.1. So what will happen? This 0.1 will be get truncated. So this will return the value, that is 8. Similarly, integer of square root of 5. So square root of 5, that will, you'll get a value that is 2.23 something. So the fractional part will be truncated, you will get the value 2. Similarly, this is integer of minus 7.5. So this will return the value that is minus 7. So similarly, there is integer of the integer. So simply just it will return the value as it is. The next important function is absolute value function. So it is indicated by this, the modulus of x is defined as greater of x or minus x. So for example, this is minus 123. So just it is nothing but 123. Just to consider the magnitude irrespective of the sign. So it is 8.1, just it is 8.1. Similarly 4.45, there is no sign, just simply it will return the same value. So the absolute value irrespective of the sign, just to consider the magnitude, this will return only the magnitude, only the quantity irrespective of that sign. That is absolute value. The next one is summation. It is indicated with the symbol sigma. Let a1, a2, etc. an be a sequence of numbers. The sum of a1 plus a2 plus etc. a3 an can be written as summation of j is equal to 1 to n a suffix j. So this j, it is a dummy index or dummy variable. So its value will be, that is incremented, that is 1 by 1. So 1, 2, 3, etc. etc. Here the summation of the natural numbers can be written as sigma j is equal to 1 to n. J takes values 1, 2, 3, etc. up to, that is n. So this can be written as, this is nothing but n into n plus 1 by 2. So this is a formula for calculating the summation of the natural numbers, n natural numbers. The next function is factorial function. How actually we are doing the addition, like that we can do successive multiplication in factorial. So factorial function, that is n factorial, denotes the product of positive integers from 1 to n. So n factorial is equal to 1 into 2 into 3 into etc. n minus 2 into n minus 1 into n. So for example, if you say that is 4 factorial, it is nothing but 1 into 2 into 3 into 4. So just if you multiply, it is 24. For n greater than 1, so we have this n factorial. So this can be written as n into n minus 1 factorial. Okay, for n greater than 1. Hence, for example, if you have 6 factorial, 6 factorial can be written as 6 into 5 factorial. So this 5 factorial value, it is 1 into 2 into 3 into 4 into 5. It's nothing but 120. So 6 into 120, we'll get the value, that is 720. That is the result. The next function is permutations. Permutation of a set contain n elements. It means arrangements of the elements of the set in some order. If there are n elements present, then there will be n factorial permutations are possible. Example ABC. So with the help of these 3 elements, we will get the combination, the permutation ABC, ACB, BAC, BCA, CAB, CBA. So we got 6 permutation. So n is equal to 3, then the 3 factorial, that is 1 into 2 into 3, it's nothing but the 6 So we got the 6 combinations, 6 permutations of elements possible with 3 elements. The next function is exponent. Exponents means how many times a number is multiplied by itself. If m is a positive integer, then a power m is equal to a into etc. m number of times. So a power 0 always it is equal to, that is 1. Anything to the power that is 0 is always equal to 1. That you have to remember. Similarly, 1 divided by a is equal to a to the power minus 1. Similarly, a to the power minus m can be written as 1 by a to the power m. Similarly, a power m divided by n is equal to n square root of a whole to the power that is m. See, for example, that is a 2 power 3 is nothing but 8. Similarly, 2 power minus 4 can be written as 1 divided by 2 power 4, that is 1 by 16. Similarly, this 125 to the power that is 2 by 3 can be written as it is a cube root of 125 whole square. Cube root to 125, it is nothing but 5 square, which is equal to, that is 25. Similarly, the next function is logarithms. The log of any positive number x to be base b written as log x to the base b. It represents the exponent to which b must be raised to obtain x. So y is equal to log x to the base b. Similarly, b power y is equal to x. Both are same. So what you have to do? See, for example, log 8 to the base 2 is equal to 3. This means 2 power 3 is equal to 8. Similarly, log 100 to the base 10 is nothing but 10 power this 2. So the base is 10 and 10 square is equal to 100. We have to remember some important note as far logarithm concerned. For any base b, log 1 is equal to 0. Whatever may be the base value, log 1 is equal to 0 because b to the power, anything to the power 0 is equal to 1. Similarly, log b is equal to 1. So here the base and the value both are same. So b power 1 is nothing but b only. Different classes of logarithm. So log to the base 10 called common logarithm. Log to the base e called natural logarithm. Log to the base 2 is called binary logarithm. That is log x or log x to the base 2. Okay, so both are same. So in this video we have discussed the different mathematical functions which are required for the data structures. I hope you understood. Keep watching. Thank you.